Now let's say we have to insert a node in between the two nodes in doubly linked list. So here we will consider that there are two nodes in the list and we have to insert in between these two nodes. Okay, so let's say we have to insert this node in between these two lists. So what are the things that we need to do? So the problem statement might be something like this, that search for element 5 and insert a node 8 after this particular element. So you have to insert 8 after 5. So the very first thing is that I search that where is 5. So we will have our head. So just like we used a temp node to go at the end of the list, we will use a temp node here also to reach to this particular node. So initially our temp node is pointing to head. So we will have our temp node pointing to head. So let's also write down the process here. So we create a new node, temp node, which is pointing to the node that is getting pointed to by head. Okay, so initially head is pointing to this particular node, so temp node also starts pointing to this particular node. Now what we will do is we will run a loop unless we get 5. So there are two scenarios. Number one is that let's say the element is not there. So obviously there, in that case, we'll have to end the loop when we reach the end. And in case the element is there, we have to do the insertion. So I run a loop while temp node not equal to null. So it might happen that we keep on searching in the list and we come to this particular place which is null. So temp node will have value as null. So we have to make sure that temp node is not null, or for that matter even if the list is empty. So this temp node will become null. So we have to make sure we do temp node not equal to null and temp node dot data is equivalent to not equal to num. Okay, so what we are doing here is we are checking that if temp node is not null and the data is not equivalent to num. So let's say the num is 8. So if data is not equivalent to num and this node is not null, what do we have to do? So let's say we come here, we check if 4 is equivalent to 8, which is not the case, then obviously we'll have to move to the next element. So what do we do in this case? We simply do temp node is equivalent to temp node dot next. So using this operation, let's see what happens. So initially our temp node is pointing here. We check if temp node is not equal to null. So this is true, temp node is not null. And temp node dot data not equal to num, which is again true. So we get into this loop, this gets executed, temp node starts pointing in here. So now what happens is that we check temp node not equal to null. This is true, but this becomes false because data of temp node is equivalent to num. Oh, I'm sorry, it's going to be, num is going to be 5. Here, it's going to be 5. It's going to be 5. So we get our temp node start pointing to this particular place. Now let's see how do we do the insertion. So now let's say we have head here. Our temp node is pointing to this particular node. We have to do the insertion after this node. So the very first thing we have to do is we obviously have to create a new node, and we want the new node to have data as 8. So we create a new node, new node, we name the new node as new node is equivalent to new node 8. So the constructor gets called and a new node is created in the memory. Now this new node is created in the memory with both next and prev pointing to null. We have to put this in between these two nodes. So let's see what are the operations that we have to do. So if we see this particular node, for this to come in between these, the next of this node, let's say I call this N1 and I call this as N2. The next of N1 should point to new node. So I say next of N1 should be new node, okay? And then the next of new node should be N2. Next of new node should be N2. So we have done this, but here we have just updated next. We also have to update our prev. So do we need to make any changes in this particular prev? No, N1 prev of N1 need not change, okay? do we need to change prev of this particular node? Yes, we do need to. So the prev of new node should be n1, and the prev of n2 right now is pointing to 5, but it should point to this particular node. So prev of n2 should be new node. So we have to perform these set of operations to make sure that this is getting inserted in here. So we have written it down. Let's see how do we write code for this. So how can we implement this particular line? So right now our n1 is pointed by temp node. We simply do temp node dot next is equivalent to new node. Now next of new node should be n2. So if you see this, you see that there is no one which is pointing to n2, right? So the only way to access n2 was that we access the next of 5. So what we have done through this operation is we have updated the next of this n1 to point to this new node. So next is now pointing to this new node. So I have lost reference to this particular node n2. So whenever you are writing code, make sure that you're not losing reference to any particular node. So it is really important that these 4 operations that you have to do, you make sure that you are doing it in a particular sequence. Else, as you can see, that we get an issue here. So what do I do now? So let's say first what I do is I update next of new node. So when I update next of new node, we will get reference to n2 obviously. So we will not do this first. So the first thing that we will do is we'll update new node dot next is equivalent to temp node dot next. So if this is my new node, the next of this is now pointing to this particular node. Now we have to now update prev of this particular node. Now since we have a reference to this particular node, this new node next is this node, I can now update next of this particular node. So I can do temp node dot next is equivalent to new node. So now we have updated all the nexts. We have to now update the prev. So let's update the prev of new node. So new node dot prev is equivalent to temp node. So now the prev of temp node, new node is pointing to temp node. So now what are the latest links we have? New node dot next equal to temp node dot next. So this is there. Temp node dot next equal to new node. So this is also there. This is broken. And then we have new node dot prev equal to temp node. So this is also there. Now one thing that is left is that the prev of this particular node, which is n2, points to new node. So how do we do that? So the only reference to n2 that we have is that n2 is the next of new node. So what we do is new node dot next. So new node dot next is equivalent to n2. Okay, and we have to update prev of n2. So we do new node dot next, which gives me n2 dot prev. So this is equivalent to n2 dot prev. This is going to be new node. So these are the operations that we have to do if we have to insert a node after a particular node in doubly linked list. So we have seen all the insertions. Let's see the code for it. So till now we have this particular list 5, 4 and 8. Let's say I want to insert 7 in between 4 and 8. And we have seen that in order to insert any node between two nodes, what we have to do is we have to update next and prev of this particular pointer. We have to, of this particular node, we have to update prev. So let me write it down. Prev of this particular node, and next of this particular node will point to 7. So we have to do something like this. 7 next points to 8. Prev of 7 points to 4. Next, this link gets broken. Next of 4 points to 7. And prev of 8 points to 7. So let's see how do we do this. So the very first thing that we have to, So the very first thing we have to do is we have to come at 4. So let's say I have to insert after 4. So let's say I write a method in which I pass, its name is, let's say, insert after. I pass two values. Number 1 is the number after which I have to do the insertion, and number 2 is the value of the new node that is getting inserted. So let's write down this particular method, void insert after. It accepts two parameters. Let's say the first one is num and the second one is data. So here what we have to do is we have to reach to that particular node which is having value as 4. So I have temp node which will help me in the traversal, is equivalent to head initially. Now we run a loop that while temp node is not equivalent to null. So this is really necessary that I check that is it not the case that I have come to the end and temp node is not null, because if we don't put this particular case, it might happen that the value is not there in the list. We have reached to the end of the list, temp node is null, and when we try to do temp node dot data in that particular case, we will get null pointer exception because we are trying to access something out of a null. Okay, so we do this particular condition and temp node dot data not equivalent to num. So if this is the case, I'll keep on updating my temp node. So after this particular operation, what will happen? So initially my temp node is here, so my head is pointing here and my temp node is also here. So temp node will check this particular list, this particular loop will check that if temp node is equivalent to null, which is not the case, and neither this temp node dot data is equivalent to num, so this will be true. Temp node goes to the next data. This at this particular place, temp node dot data is equivalent to num, so the loop gets broken and my temp node is pointing to this particular place. Now I have to do the insertion after temp node. So what we will do is, obviously we'll create a new node. New node is equivalent to new node and we'll pass the data. So this creates a new node. Now I have to update next prev of new node, temp node, and the node that is after the temp node. So what we will do is we'll first update the next of new node. We will update prev of new node next. We will see what other things happening here. We have already seen once while we were discussing these things. We'll see them again. So what is the next of new node? So the next of new node is 8 now. So the next of new node is 8 and we want to change prev of 8. So what will prev of 8 point to? It will point to 7. So we do new node dot next dot prev is equivalent to new node. Now we have to update prev of new node and next of temp node. So the next of temp node is going to be new node and the prev of new node is going to be temp node. So now let's first print this list to see that whether the 7 got inserted or not. Okay, so as you can see that we had initially 5, 4, 8 and now we got 5, 4, 7, 8. So 7 got inserted. So if we quickly dry run this code, so initially we had 5, 4 and 8 and we wanted to insert 7. So when we run this particular loop, temp nodes come here and now what we do is we create a new node. So this new node with data as 7 is getting created somewhere in the memory. We have to put it in between these two nodes. So what we do is we update next of 7, temp node dot next is equal to new node dot next is equal to temp node dot next. So the next of new node is going to the point next of new node is going to point to next of temp node. So what is next of temp node right now? This one. So this link is going to get created. Now new node dot text dot prep. Okay, first let's see this part. New node dot next. Who is new node dot next? 8. So prev of 8 is going to be new node. So this link is going to change. Now what we're doing is temp node dot text equal to new node. So now this link is going to change, and the prev of new node is going to be this node. So we get this particular list. Now there are various things that we have to check here. Number one is that we haven't checked for head, whether head is equal to null. So obviously if head is equal to null, we do the same thing. So even before doing this iteration, we have to check this particular thing. So in that case, we'll have to make the new node before this particular loop. So even before running to this loop, we have to check that whether there are elements there or not, and we have to do if head is equivalent to null. Anyways, this loop will fail because we have put in this particular condition. Still, this is one thing. Another thing is that we have to check the next of temp node is null or not. So it might happen that the value that we are looking for, after which we have to do the insertion, is the last element. So while writing, we have to keep these things in mind. So here when we are doing temp node dot next dot prep, so here before doing this, we have to check that if new node dot next not equivalent to null, then only we will do new node dot next dot prev. So if this thing comes out to be null, then null dot prev will give me null pointer exception. So if we talk about the time complexity, so in this case again the time taken to reach this particular node after which the insertion has to be done is O of n, and time taken for insertion is O of 1.